We're going to be looking at whether or not lines are parallel or perpendicular or even neither. I want to talk about that. Neither could be an option. Remember, parallel means slopes are exactly the same. Perpendicular means they're opposite and reciprocals of each other. So sometimes you may see that slopes are opposites only. That doesn't necessarily mean that they're perpendicular, because they could be neither also. Just like with their reciprocals. If they're reciprocal, they don't necessarily mean that they're perpendicular. What is all this stuff here? All right. Here's our first set. I would like for you to write down these ordered pairs. If you would like, you can write them as like a little table, which is what I've been doing today, just to kind of set them up for slope. So 9, -5, -3, -3, so that we have it to find our slope. And you can do the same thing with the other set. -11, -6, -5, -7. So then from here, what we can actually do is find our slope. So I'm going to find my change in y, in this case is a +2, while my change in x over here is a -12. So then I would have 2 over -12, or when I simplify, -1/6. Same thing down here, I go from 6 to a -7, so that's a -1, and this would be a +6. So then I end up with -1/6. So what can you tell me about those two slopes? The slopes themselves are the same, which then in turn makes these lines parallel. Okay. Here's our next set. So I'm going to set up my ordered pairs. Let's see, -6, 11, -5, 11. And then my other set would be -8, -4, and then 7, -4. Hopefully you're noticing that the y values are the same on both of those ordered pairs. This means that the change in y is going to be a 0, which means the numerator is a 0. And then that means the denominator, it doesn't matter what it is, because you're always going to get 0 back. Once you discover that the y's or the x's are the same, you know you're going to have a 0 somewhere in there. So in this case, same thing. 0 in the numerator, denominator is that, and then we have a 0 again. So because they're both 0, that means they're the same, which means these lines are parallel. And just to kind of clarify, the equation for this one would be y equals 11. This one would be y equals -4. Because they're both y equals, that makes them both horizontal lines that are parallel. Okay? So far, so good? Yes, yes? Okay. For the next one, ordered pairs, setting up my little table so I can find my slope. Oops. Okay, so in this case, I'm going to start with my change in y. My change in y in this case is a +13. Well, the change in x is a 0. You cannot divide by 0, so that means we have an undefined slope. Now when I go down here, my change in y is 0 this time. My change in x is a plus 9. Anytime you have a 0, you're either going to have undefined or 0. So in this case, this one would be 0. So if we have an undefined and then we have a 0 slope, what does that mean for us? They're perpendicular. That's, oops. They are perpendicular. That's right. Because remember, that would mean a horizontal and a vertical line, which then in turn makes them perpendicular. Just to kind of talk about this equation right here for the first one would be x equals -5, and then this one would be y equals 6. And the reason it equals 6 is because both points have 6 as the y value. Both points have -5 as the x value. Next one. Now we have equations that we're going to be looking at. So we have y equals -1 and then x equals 6. When y equals, that's a horizontal line with a slope of 0. X equals is a vertical line with a slope that is undefined. So we have that same situation where we have vertical and horizontal. So therefore, that means these two equations would create lines that are what? Perpendicular. Okay, now the next one we have here, we have two equations, but they are in standard form. So that doesn't help us much because what we need to do is get that equation in y equals mx plus b format. So we need to know what the m is in order to know whether these lines are going to be parallel, perpendicular, or neither. So I'm going to take these equations and I'm going to solve for y. So y equals x minus 9. That's weird. I don't know why. Okay. Now I'm going to go ahead and take care of the other one here as well. So I'm going to start by moving that 7x. So I have 7y equals -7x plus 35. Divide by 7 on everything. So y equals -x plus 5. Now I'm going to go back up to the one I did in purple here. And I'm going to ask you, what is the slope of this guy? Does it have a slope? What is the slope? Very good. So our slope is 1 for this one. What about the slope for that second one? -1. All right. So now we need to decide, are these equations going to create lines that are parallel, perpendicular, or neither? What do y'all think? Think perpendicular? Let's talk about this. Say that again. So let's see. Parallel. Definitely not parallel because they're not identical, right? Now perpendicular. Let's think about this. 1 as a fraction is 1 over 1, correct? If I'm going to write the negative reciprocal of that, it would be -1 over 1. What does that mean? They're opposite reciprocals of each other, right? Because 1 is the same when it's a reciprocal. It doesn't matter. So then in this case, they would be perpendicular. Good job, Stan. And here's graphed for you as well, so you can see that they are perpendicular. They do form those right angles that we are looking for. All right, last but not least, I want you to decide on your own for this one.